Hey everyone! Thank you so much for watching another episode of the Weaviate podcast. I'm super excited to welcome Jason Liu. About 3 months ago, Jason presented Pydantic is All You Need at the AI Engineer Conference in San Francisco. It was such like a novel, but also kind of straightforward, easy to wrap your head around way to achieve structured output parsing with LLMs by using type checking and schema validation, all packaged in this Instructor library. And Instructor is quickly becoming one of the most popular, impactful projects, open source projects in AI. And Jason is becoming one of the most impactful people in AI. Jason has so many incredible blog posts and lessons on RAG engineering broadly. I really like the one you did about embedding all of Wikipedia in 15 minutes for $15 on Modal. I was just like, I can't believe that we've come that far that you can do that. And all sorts of interesting things. I think your experience as an independent consultant, jointly backed with this experience with StitchFix and Meta, it just gives you all the potential in the world, all the authority on speaking openly about these topics. And so, Jason, I'm so excited to welcome you to the podcast. I'm sure I'm going to learn a ton in this conversation.
I'm very excited. Thank you for having me.
Awesome. So, could we kick it off with kind of the overview of Instructor? What kind of led you to create this?
Yeah. So for the most part, when I used language models back in 2020, right, 2022, a lot of the time was actually asking for structured data back out. When I was at StitchFix, we were able to take, for example, a request note and turn it into a search query we passed to our internal search engine, right? And a lot of that was just asking for JSON. And for the most part, until the summer of last year, when function calling came out, you had to deal with a bunch of random issues. You have to ask for JSON in a code block. You say, don't talk, only ask for JSON. But when you actually had function calling, what this allowed us to do is to allow us to specify out of band that we wanted structured data. And not only that, these models were fine-tuned to support that structured data. And so by doing this, what we can effectively do now is to give the language model a type hint and just verify that the data is structured correctly. There's no more things like JSON loads. There's no more checking if the number 13 was the string 13 or the actual integer. All these things sort of fade away, and we're left with a really simple way of programming. You have functions and you have structs. And sometimes you're going to attach methods to those structs, and now you have object-oriented programming. And all this really just makes programming with language models more backwards compatible with existing code. It's just a function. It's just a return type. There's nothing too fancy about that.
Yeah, I love that. I've seen on some podcasts you've been on, I think one of the titles is, or one of the thumbnails where they put the text by your face is like making LLMs backwards compatible. And I think that's such a powerful line. And I think it's hard to even understate the impact of this, because everyone is so excited about like chains and programs, but if you can't like pass the data to the next one, then, forget about any of that. And then it's just like, I guess there's also this idea of like, you have these examples of what if you go to the Instructor docs and notebook number 3 and doing my studying, Jason has like, doing multiple things with the input. So say you're re-ranking, and I know you have opinions about LLM re-ranking that we'll dive into, but giving the explanation as well as the re-ranking, doing this kind of like two things from the LLMs is so interesting. So maybe before we dive in any further, if we could just kind of, I'm really curious in learning more about, how Instructor solves the problem. I understand that Pydantic has this like validation built into it, but how does like the retrying work? Could you dive in a little further?
Yeah, so now Instructor is actually implemented in both JavaScript and Python. And what we do is we hook into these really well-supported, well-loved libraries like Zod and Pydantic. And so all this validation ends up being handled by these systems where there's already an ecosystem, there's already great documentation that we don't have to write. But the general idea is this. When you call function calling or tool use, you pass in a JSON schema. And this JSON schema tells you about the type information, whether or not there's nested structures. And then when you get the JSON back out, there is some probability that you might not get the right structure. There's some probability that you say, you must give me a score between 0 and 1. And maybe it gives you 10 out of 10, right? Maybe it's the number 10. Maybe it's a string 10/10. So when you have errors like this, what the library will do is it'll catch all these errors. It knows exactly where these errors are. It says, I expected an integer. You gave me a string. This is the value. This is the type. And we throw these error messages. This is what the validation libraries do. And then what Instructor does is it just nicely captures them all, formats them in a structured way, and then presents that back to the language model. So we are not retrying the same request. We're sending a new message that says, this is what you gave me. Here are the 3 error messages that I encountered. I expected an integer. This string is not one of the literals you provided. And this is an empty list. And I did not say this was optional. Right. Now, all of these errors can get passed to the language model, re-asked, and you could usually get a much better output.
Yeah, amazing. So I think that's kind of like that reflection prompting with X instead of CT, so it's like so that prompt, is that something, the retry prompt, not like retry, but retry with the error message. That's kind of like, would it be fair to say that that's kind of like the secret sauce of Instructor is, like if you were to say maybe fine tune a model, like either you could have like a prompt that really is successful at taking the original attempt with the error message and giving you the correct one, or maybe a fine tuned model specific for that task. Would that be fair to say that that's kind of like the secret sauce again? Sorry to say that twice.
In some ways, right? I guess to me, the real secret sauce is actually making the IDE really happy with these outputs, right? Because we can almost surely know that the object we get back out is the one we care about. Like that, I think, is the secret sauce. With these things like reasking, this is mostly to make the code more fault tolerant to the language model. If you use GPT-4, very rarely am I doing any reasking, right? Like GPT-4 usually does a very good job. But with these weaker models, even if you have reasking for something like Mistral 7 billion, it's very challenging for it to get you the right answer. So I guess the second part that is much more interesting but less developed or less adopted is the idea of using Instructor to generate synthetic data to do a fine tune. And so maybe this task is really difficult. I can use the validators to ensure that whether I try 0 times or retry 6 times, I get the right answer. And then I can use that data to fine tune a model that will get the right answer one shot, right? So I think in the long run, these validators won't have to exist if we build for GPT-5. And so again, the main benefit really is, this is now very tightly integrated with the way that you program.
Yeah, I love the whole programming thing, but so when function calling first came out, I was personally a little bit like, because I was working on the Gorilla LLM project from Berkeley, where it's like you're, fine tuning it to follow a certain API, and I was, so convinced that was going to be the way forward. But I have to admit, after learning more about Instructor, I'm like, oh man, function calling is even more powerful than I thought it was, because it's like not only following the API like get the weather, but it also you patch it with Instructor to follow this response model. And I think now you've sealed the deal with this function calling. Could you help me understand further, like, OpenAI, they debuted the function calling product. Now we see Anyscale and Mistral, they have function calling. There's also a startup called Nexus that has a function calling model. What's kind of like the state of the function calling models?
Well, so I think function calling right now is a means to the end in terms of how we use it with Instructor. With tools like the Mixtral implementations for things like Anyscale and Together, they also have things like JSON schema mode that do constrained sampling. And so I think in the future, they're almost going to be a little bit more separate. Function calling might be more like, how do you choose the right tool? Whereas something like JSON schema sampling will ensure that the output is the correct shape. Right? I think that 2 separations will be really interesting to sort of see unfold as time passes.
Oh yeah, I love that point. Yeah, like picking the tool is a whole nother. That's a tricky. I almost think you'll need to like tune the systems to pick the right tool, because it's like, how am I supposed to know if I need if I need a vector database query, or I need or let's say I just want vector search, or I want to like add re-ranking. I think you might need to have like a tuning to that. But so sorry for jumping ahead. One more thing on Instructor I think is such a fascinating topic, is the way that the Pydantic just organizes the prompts is amazing. I think that's like programming and integrating with the code base. Yeah, I like that. Like just the whole cleaning it up. And I don't know if it's quite related to that, like threaten it to output JSON and don't commit that to your repo, because I think you're still committing it. But can you help me? Like, I think my question for you is this organizing of the prompts. It just makes LLM programs, the code bases behind them, so much cleaner. What's your experience with that? What are you seeing with people adopting this?
Yeah, again, the big idea for me is the fact that these are now sort of out of band encodings, right? Like very few of us will read a CSV file by reading it line by line and then splitting on the comma and then asserting that like one column has enough values and then making sure that like the first line we parse is actually the titles of the columns and all this stuff is kind of out of band, right? And then if you think about SQL, there is the create table and then there's the select query, right? And we have understandings of how these things relate to another. In the same thing with the instructor pydantic objects, the schema is a certain way. This is the class that we've defined, right? And an instance of that class is also very well defined. And now we don't have sort of like examples in the prompt along with the schema, along with the data we're asking for. And that makes things a lot easier. I think in the past, there's been situations where, say you want to extract some data, you give it 3 examples, and then there's no data to extract. If you prompt incorrectly, the language model might just return one of the examples. And you won't notice that unless you do some data analysis and you realize like, how come 40% of all the names I've extracted is just my own name? Oh, because I use that as an example in my prompt, right? Yeah. In that same token, you run out of a bunch of CSV parsing issues because you've just specified that a certain column has a certain name of a certain type. And these things, again, when you specify them out of band, it just makes it a much more safer programming environment, in my opinion.
Yeah, and that kind of reminds me of like the ETL, like we see like Unstructured as a company, I think is really cool. And yeah, having that kind of like an instructor prompt for how you're supposed to like read a chunk and maybe like look for an author. And because I mean, it's just amazing how you have the strict typing because you have like optional arguments, like if it's there, then parse it, otherwise then it's not there, and all that. So, but kind of on this thing of just organizing the prompts like this, and in my opinion, what really caused the takeoff of LangChain is this like community sourcing of the chains. Like people were, hey, I've come up with this way of spinning up like an editor and a reviewer, and I use this to write blog posts, and everyone's, like, oh wow, I can use LLMs to write blog posts with this. And so I'm very curious if you agree with this idea that, I think that kind of the past frameworks haven't had a really great way to just like quickly show you one of these chains. Like I feel like I could tweet out an instructor schema and go viral on Twitter because of how nice it looks. And so that makes me want to ask you, like, if you think this could lead to like a Hugging Face for LLM programs where people can easily share the chains that they're using because of how nice the syntax ends up looking.
Yeah, I definitely think so. I think within a company, we already have a lot of examples where we have this like, not even a prompt library, but just sort of a schema library, right? It's the same, but it's so simple. It's almost the same thing as just having a types file in a TypeScript library, right? Like it's not, we don't really think about it as a separate thing. We don't really have, for example, a like Hugging Face for all your types, right? So in one sense, it's actually quite nice to have it be reduced to that level of it's just a type hint, right? But in practice, we do have things like this where we have a bunch of like transcript summarization APIs, right? And we have an action items type, right? And we've like written a good prompt to extract action items. And now whenever someone wants to extract action items, they just specify, action items : list action items, right? So we have a lot of these modular components that we can share. So I can definitely believe that this can be, made more public facing. And so we have like the best summary extractions, the best way of extracting like pain points out of a sales transcript. Yeah, I think that's all very possible.
Yeah, that's what I think separates it from maybe just like an OOP, like here's all the objects everyone has ever come up with, is that you also add like tools, and maybe you could have like specialized models in the middle of the chain kind of is something that I think could emerge with this. And yeah, so I think all that is really interesting. I guess, maybe I'd want to ask about just kind of like the RAG chains particularly. I know that I've mentioned the beginning example number 3 in the instructor notebooks. Like, what do you think are, maybe if we could, I think because maybe for our listeners, if we could give them a little example of maybe like what a pydantic schema for like multi-hop question answering would look like, just to kind of ground it a bit.
So one of the great things about using Pydantic is that it's very easy to define data structures that are very tree-like. A lot of the examples we think of is just, list of object, for example. But when we use Pydantic, we can almost have recursive definitions, right? And what that means is rather than having the language model in multiple steps produce, like in like a React way, produce multiple steps. Instead, we can say, give me one data structure, and this data structure has to be the entire query plan, right? As a DAG, right? And by doing that, we can basically produce the DAG using a language model and then just send it to a like workflow execution engine. Again, making that boundary between where the LLM does its work and where the workflow does its work a lot clearer. And so usually what you do is you can produce, for example, a list of nodes with IDs and dependencies and have individual questions for each one. And that can be visualized, that can be reviewed, and that can be dispatched to some execution engine.
Yeah, I love that one, how it helps you understand this idea that you could kind of like parallelize the task by having one structured output come out of the LLM. Because it's like, if you give it a complex task like, write a blog post on how to run Weaviate with Kubernetes, and say then you come up with all these different queries for all the things you're going to need to go learn about in order to assemble it. And so that's kind of one thing that, appeals to me a lot about this. But then the next thing, and I think this will transition nicely more into our RAG topics, is so let's say you want to have an LLM re-ranker in Weaviate. It's just essential that it outputs that list of ints so that the database can parse it and then resort your results. So I really wanted to ask about, LLM re-ranking, because I think for Weaviate, that's one of the lowest hanging fruits for us to start using Instructor. I guess also I'd want to ask about Instructor Golang, because we're going to need to figure out. I'm curious about, well, I don't mean to put too many things in this question, but I am curious about how much of the heavy lifting that Pydantic does and how much you could just kind of write from scratch with kind of validating the types of the schema.
Yeah, I mean, the library itself, the base of it really is about like 200 lines of Python code, right? Most of the work is actually around organizing the type hints so your IDE is very happy with the results, right? Like most of the work actually is around, if you do result equals like instructor.create, that all the attributes autocomplete, or whether or not you try to access an incorrect attribute or have a typo, that's all cleaned up for you. I think for the most part, I've been challenging a lot of folks to think about what an instructor like pattern could work in their language. For example, in Elixir, we have Ecto. I think we have a instructor like API in Rust. A friend of mine has written one in Go. And so, yeah, I think a lot of it is just, organizing sort of what are the main criteria that we need to make something that is very like instructor like. And really it's just the response model and IDE support for the type hints.
Oh, it's so interesting. And I'm going to have to ping you about that Go library, because I think we can really use that at Weaviate.
And the example you mentioned with re-ranking, something that's very simple could just be when we generate the re-ranking, we have a validator that verifies that every ID actually exists, right? If you just use IDs from like 1 to n, there might be a chance that there's a hallucination. But if you have an ID that is, a 3-character code, there's a less likelihood of hallucination, right? And if we just verify that these 3-letter codes must be within a certain set of these codes, we now have a hallucination proof system, because all of these things are now verified.
Yeah, it's amazing how much that unlocks it, and how much without that you're in trouble, because
exactly.
Otherwise you're just using exactly the like, please output this, please follow this instruction.
Right. Or you just have some code that says for each of these IDs, like check that it's a substring of the return string, right? But then you can just get into a bunch of different weird cases. And again, you're doing a lot of like in-band work when you really don't have to.
Yeah, amazing. So I think, so hopefully this is a good coverage of Instructor, and I'm sure maybe we'll come back to it. But I think this unlocks so much of retrieval augmented generation, LLM programs. And so maybe if we could kind of kick it off broadly on, I know you have this really interesting background as an independent consultant. What are the kind of some of the things about RAG that are interesting you the most right now?
I mean, the biggest thing is the fact that I see most of retrieval augmented generation almost identical to the recommendation system work that I had done at StitchFix for the past 5 years. So to explain the StitchFix model, what happens is a human client makes a request that says, hi, I'm going to the beach next Friday. I would love to have some dresses. Also, I'm going to a wedding, so I need something a little bit fancier. And then what we do behind the scenes is we take that and produce a carousel of recommendations, right? We source from the inventory that we have and we make these recommendations. And then we show these recommendations not to the human, but to a stylist. And then the stylist has to then take these recommendations and then finally produce a last set of things that we then send to the user. That's basically RAG. Except instead of a language model, we have a personal stylist, right? You have inventory, we show the stylist picks that and reorganizes and sends it back. And so all the things we have thought about in terms of observability, of infrastructure, of how we can sequence this work, where the re-rankers live, all looks like RAG. And so a lot of my consulting now is kind of just bring that expertise to these folks who are trying to build out more complex applications.
So I think if I can double click this, something Bob says that I've started saying now, but if we can double click on the recommendation analogy, I guess there's a few things to recommendation and search that I think, first of all, you have to have a user representation. Like in it, like I think with this query of I'm going to the beach and then I have a wedding, you also need to know, like, say I like salmon colored swim shorts or something, like you have this kind of user representation problem as well. So the first thing I wanted to do is maybe pitch you on one of our Weaviate features, and feel free to roast it if you want.
Of course.
So we have this thing called reftivec, whereas like you'd represent Connor as the average of interactions. So say I come to StitchFix and I'm sorry, I'm not too. I think StitchFix is the engine underneath the right. Yeah. So let's say I'm on Nike and I come and I like 3 basketball shoes. You would average the vectors of those basketball shoes to then be the vector for Connor, and then you search with that vector. And so I think already reftivec does have this limitation of like, you're only going to get basketball shoes now. And so something that we're looking at is like multi-vector, where we're like cluster those vectors. And so that's kind of something that's on our roadmap. And, I know you've done this work with like collaborative filtering and like, an SVD style way of getting the vector out. And so, yeah, I'm just curious what you think about user representation broadly and maybe reftivec.
Oh, yeah. I mean, the stuff that we did at StitchFix was even more complex. We actually had a transformer model generate embeddings that had like a time series component, a profile component, right? So there's things that you tell us, there's things that you buy, there's things that you look at, and things that you add to cart but don't include. And all these features end up boiling down to a single vector. And then what we actually do behind the scenes is we do diversity sampling, right? So instead of rather organizing the vectors this way, we can organize them as we make the recommendation. But overall, yeah, I think that the right way to do things will end up ultimately being multi-vectors, unless you're able to fine-tune something that is specifically to your use case.
Yeah, well, because I think with multi-vector, you can, reduce the dimensionality of the vectors to something like TSNE or UMAP, and then you can cluster them with HDB scan, and then say you get 3 recommendations from this cluster, 2 from this one, and 5 from this one. And then you also have this Pinterest wrote a really nice blog post about like that. Now you have like a multi-arm bandit problem of how you're sampling from each of the clusters, and yeah, so all that is pretty cool. And but the thing you mentioned about using a transformer to aggregate the clusters into one vector, I guess I'm pretty curious how that might look. It's almost like a graph neural network then, right? Like, well,
I would treat it almost more like a matrix factorization problem, right? Because we have these like very deterministic sources of data. We have a sequence of impressions, we have a sequence of checkouts, right? And we can use that to effectively predict what the next impression should be, what the next checkout should be.
Yeah, I love that you brought up the sequence thing. I think you have to, what we have to do with our reftivec is time weight it with the vectors in the interaction. And so, but that time weighting component, the sequence part, that's what makes me want to talk to you about re-rank or LLMs. In particular for recommendation, I'm pretty excited about them. And because I think the thing is you can prompt the LLM with, I just showed Jason LeBron James shoes. He viewed that for 3 seconds. Then I showed him Kobe Bryant shoes and he looked at that for 2 seconds. But then I showed him Lionel Messi shoes and he viewed that for 30 seconds. It's like giving it that sequence in the prompt is now like, I'm going to show more soccer shoes. So that's kind of what makes me like, I think it's such a, it is kind of use the LLM as the hammer for all the problems, but I do think it's such like an easy way to kind of add it on to your,
Yeah. And for the most part here, like while I don't use a lot of LLMs to actually re-rank things in a production setting, using these LLMs to produce the training data, to bootstrap the training data in the absence of a product launch is massive, right? Where day one, before we launch, let's go just spend $50 on GPT-4 credits, generate 50,000 examples. And then we can now train a much faster, lower latency re-ranking model. Then as we get more production data, we can slowly wean off of the LLM data and then use production traffic, right? Or just never wean off and just say, today we have 100,000 examples. As we get more users, as we get more impressions, we'll just have more real data and it'll eventually learn something more on distribution. But I think, yeah, using LLMs to generate that data is an incredibly powerful opportunity.
So would that look like I have LLMs that have like a persona role, like and so then you're simulating how it might react to recommendations. I know that Google had this thing called RecSim that was like this kind of idea, and yeah, that does sound super powerful. But the other idea you had mentioned is this like kind of lightweight re-ranker until you have enough data, and then I assume once you have enough data, now the prescription would be fine-tune an embedding model.
Or fine tune any kind of like ranking model, right? I think you would use embeddings to probably power a ranking model. But I bet if you had an embedding model, I bet having more time signal could be super important. You could have like the zip code of the person depending on what kind of clothes they buy, and so ultimately it ends up being just a re-ranking model where embeddings are probably one of the more effective features for that model.
So embeddings is one of the features that makes me think that you're thinking XGBoost style rankers rather than like like T5 hosted with Olama. I don't know if T5 has made it to the Olama
I guess
catalog.
for me, the biggest concern is mostly around how much of it can be pre-computed and what is the latency constraints, right? In an e-commerce setting, 100 milliseconds could be the difference between $1 million and $2 million, right? And so if T5 is 30% more accurate, but it's 5 times slower, it doesn't actually move these business outcomes that I really care about. And so in practice, my favorite thing to do is to do as much pre-compute as possible with neural networks. Sorry, I mean generative AI. I still feel very old when I say things like neural networks now. With deep learning, let's do all this work behind the scenes. Let's have like 3 different embedding models, right? Let's have all these features extracted. And then in the inference step, let's compute 4 dot products, which might take 10 milliseconds, and then just use like logistic regression, right? Then for every inference, it might only take 20, 30 milliseconds, right? And for an e-commerce situation, that maybe makes a lot of sense. For question answering for legal documents, maybe that doesn't, because they're willing to wait 30 minutes to get a good answer. But I think in production, a lot of it actually comes down to our latency constraints and whether or not that affects things like churn, rather than just some kind of like machine learning evaluation metric.
Yeah, I think what you're saying is super powerful. It reminds me of a really throwback Weaviate podcast. I think like number 15. I think this is going to be like 87.
Incredible.
With Eric Bernson, when he was describing like the invention of the Annoy library at Spotify and how they pre-compute all their recommendations offline. And Dimitri Khan had done, if you're following along the search relevance, he did this really great talk about that like 30 seconds costs you $1 million in e-commerce. But I guess like maybe my pushing back on that would be, I sort of think that with generative AI becoming more like well known, that people might be more interested in these sort of like conversational shopping experiences. And I think in that setting, as long as you show them like the 3 dots moving, you might be willing to tolerate more latency. I guess that's like
I have a bunch of feelings there, right? Every back and forth is a probability of you not checking out.
It's a Markov chain.
But you think about it, right? Like if like Amazon, I don't know if you knew this, but I think Amazon has the mean time to check out on Amazon for a search request is like 35 seconds. Right? And that's because when someone searches on Amazon, if it's faster, usually it's like a stolen credit card. But like, which is also true. But like, but generally, like when people come to Amazon, they almost know what they want, and they just want to be unimpeded in purchasing these decisions, right? So again, it's like if Amazon takes 30 seconds, a conversation is going to take 2 or 3 minutes, and any moment you could be distracted and be taken off that path. I think that's why it's something like character AI is actually so effective, because these language models are optimized to increase time spent, right? And so they'll say things like, "Oh, come back," like like don't leave and stuff like that, which is crazy. But yeah, I'm very curious like how something like this could be applied to the e-commerce world where time to checkout is so important.
Hmm. Yeah, and that is a nugget that I took from your Attention Heads podcast. And to the Attention Heads podcast, I'm sorry it took me so long to give you the reference. It really, you did a fantastic job interviewing Jason. And one thing that you mentioned was this kind of like the way that Instructor allows you to stream outputs with structured things. So like if I'm re-ranking the IDs, I could stream the IDs back, and then maybe I can solve this latency by, if I'm re-ranking like 1,000 things, I can get the first two and start showing you something as it's still going. And maybe that's the solution to this problem that we're talking about now.
Definitely think so, right? If I would challenge people to actually time how long it takes for ChatGPT to finish writing a result. It's usually like 25, 30 seconds. But because we can start seeing the title come out, we feel a lot better about these things. And I think in practice, without streaming in any production application, for the most part, you're likely like dead on arrival because it's going to be so much lower.
Yeah, no, I'm sold on streaming. I think also with like the Olama, I've been doing like a little bit of timing it, and then I also got roasted in the Olama Discord that I'm not timing it right. That using a Bash script and having to time it isn't the right way to do it. But
No.
yeah, awesome. So I really want to transition also into this topic of I wanted to talk about ETL for LLMs and companies like Unstructured, and I think also kind of like knowledge graph completion, like something that, Bob, CEO of Weaviate, he really loves this like knowledge graph stuff. And we always come back to our knowledge graphs making a comeback yet or not. And I think this kind of like instructor's schema for like how you might extract knowledge graph style tuples from, text chunks, this might be the argument for the return of the knowledge graph.
Yeah, I mean, I'm pretty bearish on these things. So if you want my take, I can go there as well. But for the most part, I think ETL for LLMs as a company makes a lot of sense, right? There's a lot of unstructured data out there. I guess my main curiosity is really understanding like where are as a consultant at least, one of my big questions like where is the actual like business value like happening, right? If it's very simple things like extracting tuples, generically it's really hard to sort of provide value for any kind of industry. Whereas I think the ETL for LLM companies that are going to do really well are the ones that will tackle specific verticals, right? Like if you just go into insurance, or if you just go into like processing PDFs for like solar panel installations, then I think that those businesses are going to do incredibly well because of how you can market the product. Whereas for something like more generic, you're almost just better off using something like Instructor and like a table extractor to get your data back out.
Well, I think that argument is one of the biggest arguments in AI, and it's seen in so many different flavors. Like Voyage embeddings, for example, just released like Voyage code, and so it's like if you're searching code, then that's one to use. And I don't know where I stand. Like I guess there is a couple of things with this. With embedding models and maybe like OCR. So it sounds like your position is like if you're ingesting like PDFs of insurance claims, that's a different model than let's say pitch decks, and you're like a angel investors. So I guess I definitely can see it. I guess like I'm sort of in the. I don't know. I change my position on this all the time. It's a tough one. Like whether you're in the zero shot, there's just some super powerful model that you can then kind of like prompt it and steer it in that space, or if you need the fine-tuned model.
Yeah, I guess here again it goes down to the fact that like unless you can tackle these very specific verticals and you can find the very long tail of like idiosyncrasies, it's very hard to sort of like make a very strong business, right? Because the things that end up being valuable is the data itself. Like I think a lot of these ETL for LLM companies, like for the most part, I think it's just like how many gigabytes of data do they store for somebody? That's the thing that they can probably charge the most on, not necessarily the extraction itself, because that's so cheap, right? Whereas if you do something like construction documents, if you're very good at parsing like part specifications, you can extract a lot of value because you can be much more efficient. Whereas like if it's only 90% accurate, you're never going to be able to sell that product to a specific vertical.
Yeah, I think that's a fantastic point. I guess One other thing about it that I like is like for me, I don't really think that vector databases are a great solution for knowledge graphs. I would recommend using like a knowledge like a graph database for a knowledge graph, and so I think that's another opportunity for ETL is you take it out of an S3 bucket and you extract the tuples for your knowledge graph, or you just chunk it for and embed it for your vector database.
Yeah.
And so I think that's another one of the opportunities for them with the whole ETL for LLMs. Yeah, I think that I guess the reason I wanted to ask you about that particularly is I do think Instructor and coming up with that schema for how you're going to use the LLM to parse the chunks and for each of these different databases, I think it'll just be absolutely essential to it. Awesome. So the next topic I really want to talk about is transitioning to your modal experiment. I was so surprised when I read the headline of it. I know that Cohere has some really amazing like batch embeddings APIs, but I don't think I've seen, a headline like that. All of Wikipedia, 15 minutes, $15. It's quick to
Yeah.
wrap your head around. Yeah.
Yeah. So one of the things that I also work with is a bunch of like infrastructure companies try to figure out how to use their tools and how to sort of, again, sort of explain where the value really is, right? And yeah, I think Cohere had done a great job with offering like Cohere embeddings for all of Wikipedia. And one of the things I really wanted to highlight for the modal experiment is the fact that one, local models are very cheap, and two, being able to scale horizontally is very beneficial because it's not just the fact that you can embed all of Wikipedia, it's the fact that you can do it in 15 minutes, which means if you fine tune a model, you get your new answers in 15 minutes, right? If you fine tune many models and wanted to evaluate your pipeline, maybe you want to change the text chunk size or the overlap. All these experiments will take 15 minutes. And so in a single day, you could have run 7 experiments, whereas before on a single GPU, that takes 15 hours, right? So, and that might also only cost $15, right? And so a lot of it here is the fact that if you can run these things faster, you can actually experiment more, learn more, and explore more about how you can actually build something useful. Because simply put, it's only 15 minutes because we scaled out to 60 GPUs, right? But the fact that we can do that is very, very incredible.
Yeah, sorry to almost cut you off, but yeah.
No worries, no worries.
But Modal lets you. Can you tell me more about Modal? So Modal let you scale out to because 60 GPUs, but still only $15.
Yeah.
Yeah.
Yeah, because it ended up taking 15 GPU hours, and it's only cost about $1 per GPU, and so the math ends up looking the same, but we can just really easily scale out across that. Yeah, the general idea with Modal is they offer a very nice way of doing serverless GPU compute, or any compute in general. And so the really beautiful thing about the Modal API is we just defined a function called embed. Yeah. Right? It calls Hugging Face. It creates this inference server. So there's just a function called embed, and it takes in a list of strings, which is the text chunks, right? And then the way that Modal is defined, the way we can apply this is basically just embed.map text chunks.
Yeah,
and that array of text chunks happens to just be every single text chunk we've extracted out of Wikipedia. And so the API is incredibly simple to use to do a lot of these batch tasks.
Amazing. And so I think so kind of connecting it from my selfish interest with vector search is like this kind of like we discussed like offline construction of recommendation playlists and stuff. Do you think like so you've loaded Wikipedia in memory and now you apply the compute over the data in memory? Would it maybe be an idea to do vector search on GPU? Because vector search on GPUs, it could be faster than CPUs. I think NVIDIA Rapids has the library they have a method called Cagra that does it. So it's like, I think right now it's like a bit faster than HNSW with CPUs, but do you think that could be something that would be powerful is like,
I guess it's really just a matter of like, queries per second per dollar. Like as long as those economics work, I don't really need to have an opinion. I just got someone's going to show me the dashboard. But this is like completely off track, but I am a huge fan of using GPUs as databases just because of the way that like the data speed, the data transfer speed is very high. But for the most part, I think it's just a cost problem where twice as fast for 10 times more cost. Actually, it might not be the right trade-off for many people. But I remembered some examples where they were computing the locations of all city bikes in New York City. And they had done it on a GPU, and it was incredibly fast and incredibly performant.
Yeah. So sorry, I wanted to double click a little more on the GPUs as databases thing. My understanding is that GPUs are like massively parallel, right? And with databases, I'm curious because you tend to need to have like this concurrency control around like you can have like the LSM where you just like write,
Yeah.
but then you need to kind of like lock it and compact it or things like that. And so I'm not sure I understand like why you would want the massively parallel
Oh,
GPU.
this was the example of using like they were querying like city bike paths.
Okay.
So they were all sort of like sequences of like
Mm.
geospatial points, and so that parallel search compute was like very easy. And so that's why I can imagine a world where something like a vector database, uh, you know, like lat long is basically a vector database with 2 dimensions, and so you can imagine that doing a lot better.
Yeah, that's super. Yeah, I think that kind of like query planning to offload it to a GPU, and maybe you have like the files on disk. You send them the same way you did the embeddings with Wikipedia. Is you got the Wikipedia in memory, and you could send the database files, and then do all these queries in parallel. I question what I think for the offline case it makes the most sense. But sorry. So one more question on the
Mhm.
same topic is I know right now you're working on a series on fine tuning embedding models.
Yep.
And so I think that my counter argument to that would have been, well, now you need to re-index all the data, but 15 minutes, so
Yeah,
problem
exactly.
problem solved.
That's how part one sells part two.
Awesome. So can you tell me about just like your experience fine tuning embedding models? I know Nomic AI has just released like open source training data code to train it. Like, what's the current state of how difficult is it to do this?
I guess the more important question really is like, what is the business outcome we're looking for, right? So the example why I believe this is very important is because if we don't fine tune our embedding models, that's like building a version of Netflix where if you got more users or more movie views and more thumbs up and thumbs down, the recommendations never got better.
Hmm.
That just isn't a business. Or that is at least what all the Gen AI businesses that don't fine tune their embeddings will look like in the near term. But at some point, if you are someone like Harvey, where you have search requests against millions of legal documents, you're going to want them to get better as they get more users. You want them to have network effects. You want to have better recommendations, personalized recommendations. You could even have personalized recommendations per like legal client, right? Because then maybe they're only looking at like traffic accidents or something else. All these things are there to allow you to improve these models. Um, so a lot of it really is the fact that fine tuning on these public data sets might not be as relevant because then we're really trying to compete against like public benchmarks.
Hmm.
But fine tuning on your company data is going to be incredibly important because this is the only way you can differentiate, right? If you are a company that has had 20 million legal contract RAG questions answered and another company didn't, both of you are probably using GB4. But if one of you can fine tune an embedding model, that's going to be much more relevant to your use case. And we've already shown that even fine tuning on like 2,000, 3,000 examples on an open source model will outperform every closed source model on that task.
Yeah, I agree with that. I think like my dog fooding data set is searching through the Weaviate blog with, and I appreciate that betting model. I guess like something else that I think is very interesting about this is I used to write in blog like when I would be describing this, I would say, what is ref to vec? That was like my example query. But now I've published blog posts that have that example in the blog post. And so that's now the number one result.
Yeah.
And so it's like this idea of like capturing different types of relationships. Like right now I think we're all just saying like semantic similarity, right? Like
Mhm.
whatever that kind of means. But like you could also like the DPR models from Facebook, they had this like question answer. So the relationship is like this is an answer to the question, not just it's like semantically similar to this
Yeah,
question.
exactly.
Do you think that's like a emerging direction for people fine tuning embedding models to capture a specific kind of relationship?
I mean, they have to, right? Like, let's take an example of the. Let's consider two sentences, right, out of a training data set. I love coffee. I hate coffee, right? Should the similarity be greater than zero point 0.5 or less than 0.5? Right, you tell me,
I had this exact same conversation with the engineer from Cohere.
right?
Yeah,
Because I love coffee and I hate coffee should be similar because they are both statements of preferences,
yeah.
or they should be dissimilar because there's a negation. but which one it is very, context specific. If I was to build a dating app where I was embedding their bios, that might be super different. I want to maximize that distance, right? If I'm trying to extract quotes out of a first date, now they're very similar. And so again, it's you need to sort of have this business outcome you're driving towards and build an embedding model that helps you accomplish that outcome.
Why? What the question I'm thinking of asking, I maybe don't want to put anyone on the spot with this.
Yeah, I mean, I really so to be fair, all of my fine tuning I either do with sentence transformers or in PyTorch. I'm super old. I feel like even Hugging Face stuff is very new to me.
Yeah, well, I did notice something interesting with with Hugging Face's sentence transformers. I think kind of what happened is Nils Reimers left Hugging Face and sort of left the projects. and I think with PyTorch it's I guess for me, training embedding models is the challenge is you have this you have that big contrastive loss where you have cross entropy on the dot products, and I guess that loss function was always just a little bit too much for me to wrap my head around when I was younger trying to do it.
Yeah, I mean, I'm a big fan of triplet loss. It's just really difficult to find those negatives, right? And again, those negatives really depend on your use case. So for anyone who's listening, the idea with triplet loss is the fact that if you only allow things to be learned to be similar, everything ends up being too similar. But if for every example where you find something similar, you find something dissimilar, we're always pushing something away in order to get something closer together. And so there's a lot of nice properties about that. The difficult thing is it's very hard to find these negative examples, right? Because what you could say is, okay, for all the relevant stuff, randomly pick something else and say it's dissimilar. But this is the thing I really love about RAG, okay? And I haven't really tested this yet. When we retrieve documents, we can put them into the context. So we have 10 documents in the context. If we really carefully track what data is being cited by the language model, the ones that were not cited are the hard negatives. So I think we're going to be able to generate better training data by taking a look at a query and making sure that they are similar to things that were cited and dissimilar to things that were not cited. And this is only possible if the language model is very good at doing that decision making. But it gives us a way of start thinking about fine-tuning embedding models without any kind of user data.
And that's another interesting part of Instructor, right? Is you can have those kind of fuzzy assertions. Is that
exactly?
Can you actually tell me more about how you do that with Instructor? Because I know that the validate.
Yeah. So within the Instructor library, you can pass on something called a validation context, and this is just borrowed from the Pydantic validators. And what you can do is this validation context will be sent to every single validator in Pydantic and can be used as a reference. And so if I, for example, say, okay, I have a bunch of chunk IDs and the chunk text, I'm going to format that, put that into the context. What I can also, in the context of the language model, then what I can also say is, now let me take this list of chunk IDs and put that in the validation context. Right? And so when I ask for a result, I can say, okay, give me an answer, but also give me a list of integers that represent the chunk IDs you use to generate that answer.
Yeah.
And then we can have a validator that says every single integer better exist in my chunk ID list. And if it doesn't, we can throw an error that says, hey, you cited something that didn't exist. This is an issue, et cetera, et cetera. But ultimately what that does is it gives you the ability to keep track of things that were and were not relevant. And again, fine-tune an embedding model, fine-tune a re-ranker, but generally, again, improve your system without much human intervention.
So that makes a ton of sense to me. But I'm curious about it's kind of like the guardrails idea. Like, let's say it's judging is this response racist or something, right? Can you also achieve that kind of thing with Instructor?
Yeah, so we have this idea of, well, there's two things that we can do. One, I have this very cute little toy called the LLM validator, where it's a function that takes in a set of rules and then builds you a validation function. Right? So if you just say don't be mean, we'll actually use that prompt to verify whether the text is mean or not. Not only that, it'll throw another error message that is the instructions on how to fix it. So it feels very much like constitutional AI, but it's just built with like a validator and an error message. So that's one way. The second thing is, because all of these work as type hints, we also have a like OpenAI moderation type hint. So for any string, if you just replace it with like, instead of, message colon string, just do message colon moderated string, that type hint communicates to the language model and says, hey, I need you to pass this to the OpenAI content moderation tool. And so again, we're using these type hints to communicate with the language model and describe when data is or is not correct.
Yeah, I love it. It's so exciting. So this kind of anchoring question I wanted to ask you related to this is, I think it was also in the Attention Heads podcast, you describe the bike becomes a motorcycle, the motorcycle. Yeah. And so I wanted to ask, just like, I'm so curious about the future of Instructor. I mean, you have this like independent consultant, which kind of makes it like you could do anything you want, right?
Lots of fun.
Yeah.
Yeah. So when I was talking about the bike to, it's like the skateboard to the bike to the motorcycle to the car, that's really this idea of like an MVP, right? Like you don't want to have, like if you're building a bike, you don't say, well, like, let me just build the bike with no wheels and show it around to people. And let me go build a bike with wheels. And then once I'm done that, let me go build only the chassis of a car. So it's actually very opposite of how I think about Instructor. The way I think about Instructor is simply making a good knife, right? Like my goal isn't to like design the kitchen or start the restaurant. My only goal is to give you a good knife. And then this is a knife that you can take to, cook for your friends. You can take it to the kitchen and use it as part of your job. But ultimately, my only goal is to like give you that knife and then teach you some knife skills. How to use types to better influence your IDE. How can you use like async or caching better, right? I treat Inspector almost not Inspector. I treat Instructor as almost just the anti-framework, right? Like no one really says I made an application using the requests library, right? It's just something you install to make HTTP requests a little bit cleaner, right? You use Pydantic for the validation, but no one really calls it like a Pydantic app. And so my goal with Instructor really is the fact that, well, if you're going to use OpenAI, you may as well install Instructor. It'll make things a little bit easier for your IDE, and your code is now much more easier to think about.
Yeah, I think that's very powerful. But I'm also just so curious, like, because this like it kind of reminds me of Ragus, which is one podcast we did. Like Ragus, they were focused on like the LLM evaluation metric, and I think about like that like retry, like however you retry the request, it fails the request, and now you're retrying it. I feel like being like having either the best model, or like I feel like just right there is an opportunity to like kind of create this super unique thing. But I definitely agree, like just kind of the yeah, well, because I guess kind of the making it so your ID can really follow I'm curious like how that would evolve as a business, kind of, if that makes sense.
Yeah, I mean, I'm definitely not trying to make it a business because I think, yeah, I think that is part of it, right? Like because I know that the only job is to make this like very sharp knife. It's a very easy project to scope, right? The question is like, is it easier to use? Is it easier to use? For me, the business really is part of the consulting work, right? Like if you discover me through my writing or through the library, the work that I actually end up doing is around like improving your generative AI system, improving like RAG, and then using Instructor as a way of like demonstrating some of this philosophy. But yeah, I'm definitely not thinking about building out a business for something like Instructor, keeping it lightweight. And yeah, I think the main part really is like to teach the knife skills, so to speak. Half of the blog posts are just how to write better Python rather than introducing this very large framework.
Yeah, super cool. Yeah, I imagine someone is listening to this podcast and thinking, okay, I'm going to go build the LLM for retry, and that would be a cool business, I might think. But yeah,
I mean, I had a bunch of VCs like hit me up maybe during the summer of last year after the talk, but a lot of it has been, I think the space is very crowded. There's a lot of like big players, and I think people really need some tools that are just like very clean, very crisp, and something that really is very invisible, so to speak. I think if you use Instructor, you can't really tell except for the fact that you have just an object versus a string. That's really the only difference.
Yeah, but I think it's hard to understate the power of that because it really cleans it up like crazy.
Yeah.
Having
I mean, it's one of those things where, like, if you don't really see the air around you, but if it goes away, then you're struggling a little bit. I think for the most part, I struggle to program with the normal OpenAI SDK now, because everything is just like a string and like, some completion dot choices, zero message, content, function tools, name, arguments, JSON loads, right?
Mhm.
So when it
Yeah.
goes away, it's very difficult to sort of think about programming again. But I think that's sort of the one of the big benefits of Instructor.
Yeah, amazing. Awesome. Jason, thank you so much for joining the Weaviate podcast. I thought this was such an awesome overview of Instructor, the structured output parsing thing, cleaning up the code, creating the knife. And then I love hearing your thoughts on RAG and recommendation, all just so many exciting things this stuff can evolve in.
Yeah, man, thank you for having me. It was a great conversation. I love the questions that you asked.
Awesome.